Okay, let's look at our second view of related rates. We did some work previously, so now we're going to do some more. Yay! I have written and read something that we've talked about briefly, but it's really important in that you can't put a number in, you cannot substitute a number in unless it's a constant before you take the derivative. Okay, so you've got to keep everything fluid and able to move unless it doesn't move, and we'll look at some cases where a situation like that. So we actually, last time we looked at one where the altitude, remember the airplane was flying, the altitude was constant, that didn't move, so we could use that number. That's that kind of scenario here. So the first example that we're going to do, we really don't have any setup to do because we don't have a picture to draw. Our variables have been given to us. This one, we've already been given the equation. This really is like one of the most basic ones that we could do, a fairly simple one that we can do. And so we're going to jump in and do that. We've got to we've already have the equation, so we're basically already on step 5. The first 3 steps were set up, and then step 4 was write the equation. Well, the equation's already written. Step 5 was take the derivative with respect to t. So let's do that. Let's take the derivative with respect to t. So we have 2y dy dt equals 12x cubed dx dt plus 6 dx dt. Okay, and so there's our derivative with respect to t. At this point, we would substitute in. So we know what we could do is just figure out what we need. So there's several ways. What I typically do is just throw the numbers in and see what's left over. But let's kind of highlight what we have and what we need. So I have the x value. I know what that x value is. That's 1. I know what dx dt is. Okay, got that. Dx dt, got that. What I'm looking for is dy dt. That's the one I want to find. And I don't have y. That's the number that I don't have right now. So that's the number I need to go out and look for. So let's think about that for a moment. So if I have everything else but y, well, let's look back at our equation right here. So this is the equation that we were given. If I know what x is, couldn't I plug that back into the equation and find y? Wouldn't that work? So let's do that. Let's plug that back in. So let's see. So we have y squared equals 3 times 1 to the 4th plus 6 times 1. All right, so y squared equals, let's see, so that would be what, 9? So y is plus or minus 3. Now, typically our related rates problems are in context, and we would be able to figure out whether it was positive or negative. We really don't have any indication on whether this is be positive or negative. And just for, for time's sake, let's choose the positive one because, if we're talking about distance, typically that would be positive. So let's choose the positive one. I will give you the answer if it was negative. I'll give you the answer for that one in case you want to go back and double check and see if you could find that one. But for right now, let's go with the y being 3. Let's just do that option for now, just for time's sake, because we don't really know. And I'll just write ourselves a note here so we don't forget what we did. So do we know if y is positive or negative? Do we know that? And we don't. So we're just doing a sample. You would be told more parameters, or you would need to do both. But for time's sake, we're just going to do a sample. We're going to choose y is 3. Okay, so here we go. So let's substitute our numbers in. So I have 2 times 3 dy dt equals 12 times 1 cubed. Let's see, dx dt was 2, and dx dt is 2. So let's see, what is that? That's 24 plus 12 24, of course, y'all know I'm not that great with arithmetic. I'm just going to write that down so I don't mess up. Dy dt. So let's see, 24 plus 12, what is that? 36. So 6 dy dt equals 36, and we solve for dy dt, and we get, what, 36 divided by 6 is 6. And there aren't any rates to go with this problem. So that's, if there was units, excuse me, there are no units to go with this problem, but if there were, we would definitely need to put those in. So I'll just say, if you wanted to work it with, if our choice, if y was -3, then dy dt would have been -6. So that's just if you wanted to, go back and see what would happen if y was -3, we would get just a slightly different rate. Okay, and that's our very first one on this lesson. Are we doing okay? Okay.
Which one would you prefer on a test?
We would be much more specific on a test. We would let you know.
Okay.
Yeah, we're not going to give one that has 2 options and that's too confusing.
Okay.
So we would definitely let you know. All right, so number 2, we have the width of a rectangle is increasing at a rate of 2 centimeters per second, and its length is increasing at a rate of 3 centimeters per second. At what rate is the area of the rectangle increasing when the width is 4 and the length is 5? So I'm going to highlight or circle, I guess, the things that we're looking at. We need a width. We need a width of a rectangle, and we need a length. And what are they wanting us to do? They want us to talk about area. Okay, so those are the things that we need to consider. So let's do our setup. Okay, so here's our rectangle. I'm going to call this width and that length. Okay, so let's see. So the width is increasing, so dw dt equals 2. Increasing is positive. It would be a positive rate. Decreasing would be a negative rate, right? So we have to pay attention to the words. Okay, let's see. Increasing, length is increasing, so dl dt equals 3, and those are the centimeters per second. At what rate is the area? So here's our question. So dA dt equals question mark when what? When width equals 4 and length equals 5. Okay, so this is our setup. So let's go through what we did for setup. So we drew our diagram. We labeled the parts of it. We've labeled the rates with the proper variables. Then we've figured out our job. Our job is this part right here. This is what we're supposed to be doing. We're supposed to find out what is the change in area when W is 4 and L is 5. Okay, so that's our setup. So this is setup. So after setup, our next step, step 4, is to write an equation that relates the variables together. We need to relate together A and W and L. So I hope that pretty much makes sense. So if we're wanting area of a rectangle, we know that formula from our past math classes. Area equals length times width, or width times length, whatever order you want. What we need to recognize here is that this is product rule. Okay, this is product rule. I don't want you to be fooled by that. I mean, it looks very simple, doesn't it? But, it's product rule. So let's remind ourselves of product rule. Product rule was FG plus FG. First things first, second things second. Okay, so so step 4 is writing the equation. Step 5 is taking the derivative. So let's take the derivative. So dA dt equals, so we take the derivative of the first term, which is L, 1 dL dt, copy paste the second function, plus, copy paste the first function, take the derivative of the second one, the derivative of W is dW dt. I'm going to pause there for just a moment. So that is our step 5, which is taking the derivative. Okay, So now what we're solving for, I'll just highlight, this is what we want to know. That's what we're looking for, dA dt. Do we have all the numbers that we need? Do we have dL dt? Yeah, we've got that. So here's dL dt right here. Do we have W? Yep, there's W. And we've got L. And we've got dW. Wow, this one's nice. It gave us everything we needed. We don't even have to go looking for anything. We've got all the numbers that we need. So the last step, step 6, is to put all those numbers in. So let's do that. So dA dt equals, let's see, what was dL dt? dL dt was 3, and W was 4. Let's see, L was 5, and dW dt was 2. Okay, that's not bad. So what is that? 12 plus 10? Okay, let's see. Can I add that in my head? Probably not. 12 plus 10 is what? 22. Let's look at our units. Now this is units for area. So, and what are we? Centimeters? Centimeters per second. So my centimeters should be what? For area, that should be squared, right? Because area is a measurement that's squared. It's a surface. Centimeters squared per, and the time was seconds. And there's my answer. Okay? So we're easing into it. We're doing okay? Okay. So let's look at this problem on the next page, on the next slide. We actually started in another lesson. We did the setup in a different lesson, right? But it didn't have any numbers with it. This was the last lesson that we did. We set up, we didn't do numbers. So we have numbers now. So let's kind of get this all cleaned up. So we've got, let's see, the police car is coming from the north. So this way, so we really should put an arrow. This is significant. The direction that they're going is significant. The police car is going, let's see, from the north, chasing a car that's now moving east. So this car is moving east. So that's the way that car is going. I called this A. Again, you can use whatever variables that you want. And I called this car B. When the police car is 0.6 miles north of the intersection and the car is 0.8 miles to the east, the police determine with a radar gun that the distance between them and the car is increasing at 20 miles per hour. So this distance right here, they're measuring, and I'm going to call it D. Okay, so let's go back. We've got the figure drawn, so let's go back and start trying to put our variables in place with the numbers that we have. All right, when the police car, so when A equals 0.6 and the car and B equals 0.8, so that's when the distance between the car, so the distance between the car is the D, so dd dt equals 20 miles per hour. If the police car is moving at 60 miles per hour at the instant of measurement, so this is at one point in time, we want to know what the speed, so we want to know dB dt equals question mark. That's the speed we're looking for. So let's think about the rate that the police car is moving. That's dA dt equals 60. We've just been writing rates that were positive, but we really need to pay close attention to what the sign of the rate is. Okay, so it all depends on the focal point of the problem. Notice that the problem is focused on this corner. Okay, this is the corner that everything is in reference to, because we're coming north to the, coming from the north to the corner, and we're going to the east from the corner. So this is our point of reference. So when we write our rates, let's look at our, well, it said dt is increasing, so that's positive. What about the rate that the police car is going? Is the distance between the police car and our point of focus, which is this corner, increasing or decreasing? Is the distance increasing or decreasing? It's decreasing. So that means that this rate is negative. That is significant for us. It can really change our answers if we'd have the wrong sign on our rate. Okay, so that's negative. The 20 miles per hour, they said that's increasing, so that's positive, so we're good there. Okay, so those are the numbers that we need. Are we okay? So our setup, this, I'm just going to circle our setup. I just like to do that, just make sure. You know, that's our setup. Okay, so this is setup. Once we finish our setup, what are we supposed to do? We're supposed to write an equation that relates all the variables together. And this is another Pythagorean theorem that is truly quite a common kind to do, is with Pythagorean theorem. And so let's go with that. So we've got a squared plus b squared equals d squared. Okay, so that's step 4, write an equation that relates the variables together. Step 5 is to take the derivative with respect to t, 2a dt plus 2b db dt equals 2d dd dt. Okay. All right, so this time, instead of being careful and checking all the numbers, let's just throw the numbers in and see what happens, okay? And that's another way that you can do it. You don't have to be, careful and check everything. Let's just throw numbers in. So let's see, do I have A? I do, it's 0.6. Do I have dA dt? Yep, it's negative 60 plus. Do we have B? Yep, it's 0.8. dB dt is what we're looking for. I'm just going to highlight that so we can keep our mind up. That's what we're looking for. Okay, equals 2 times. Do we have D? Okay, we don't have D yet. I'm just going to put that there for right now. We don't know what that is yet. And do we have dd dt? We sure do. Well, that's 20. So we have most of the numbers, which is great. We just don't have D. So what we have to do is think about that. So is there a way to go back and find D? Is there a way? And we can, can't we? Can't we? So this triangle is fluid. Things are moving, right? A is moving, B is moving, D is moving. This is not stuck in time. I'm going to draw a triangle that is stuck in time. Okay, this triangle is stuck in time, and we've got actual numbers to put on it. So in our part, our moment in time, this would be 0.8 and this would be 0.6. And I would need, this is D. I would need to find D. So I would just use Pythagorean theorem to find D. Are y'all okay with that? Right, so it would be 0.6 squared plus 0.8 squared equals D squared. And I did that. Y'all probably already know what that is, right? That's 1. Because that's 0.36 plus 0.64 is 1. So D squared is 1, or D. In this case, D technically could be plus or minus, but in our scenario, could D really be minus? Can distance really be negative? No. So really D is 1. So for here, we're going to change this to 1. Okay, and now we're just going to do all of our arithmetic. We would have a calculator. This is what, negative 72 plus 1.6 dB dt equals, what is that, 40. So solving, I get dB dt is 70 miles per hour. Okay, we would add the 72 over and then divide by 1.6, and which I did on my calculator. And so that is the rate. So what do we find? We found the rate that the distance between the cars is increasing. The rate that the distance is increasing is 70 miles per hour. Okay, how are we doing? Okay. All right, so let's look at this last one. This one's a great one, right? This one is from our APC. I know you're going to be so upset that we don't have one like that for you to do. I mean, we do, but we didn't put it in there. Sorry, I could probably go back and change it, but we're probably fine if I don't. Okay, but if you want, I mean, practice is good. Practice is good. So this is a little bit more, this problem is amped up a little bit in difficulty, just a little bit, okay? So we've kind of eased into related rates. Here we're going to, I guess, just go a little bit crazy. So, all right, so a sculptor uses a constant volume of modeling clay. And every word is really, it's really important. We need to really pay attention. This is going to play out. This word right here, constant volume, though it seems like, oh yeah, okay, fine, constant volume. No, this is going to impact what we do. So we should notice that, like circle it, do something, outline it. So the volume is constant of modeling clay to form a cylinder with a large height and relatively small radius. Okay, so again, there's a lot going on here. I'm just going to take it sentence by sentence. I'm not going to try to jump ahead and read everything. Then I would just get really confused. So I'm going to draw a cylinder because it says it's a cylinder. Okay, we're in our setup phase, right? That's what we're doing. Okay, so the clay is molded in such a way, okay, large, so we've got height, we've got radius. Okay, the clay is molded in such a way that the height of the clay increases as the radius decreases. Okay, so that's just information we need to tuck away. The height of the clay increases, the radius decreases. We may have to physically use that or we may not. That might just be some information that, kind of helps us understand why would the volume be constant? How in the world is the volume going to be constant if this figure is changing shape? Well, this is, why, right? As the height increases, the radius decreases, apparently in such a way that the volume stays constant. That's why this is so important. The volume is constant, okay? But it retains its cylindrical shape, so still a cylinder. At time t equals c, I really wish they'd give us a number, but they didn't. At time t equals c, the height of the clay, so let's write some notes. At t equals c, the height of the clay is 8, so h equals 8. And the radius of the clay is 3, r equals 3. And the radius of the clay is decreasing, so dr dt is decreasing. So what is the sign of this rate? It's negative, right? Decreasing is negative. It's decreasing, so decreasing at 1/2 inch per minute. Let's make sure they didn't play. I don't like it when they play games with us on. So these are all inches. Okay, good, great. They're not converting. Yay. It drives me crazy when they do that, but we have to pay attention. Okay, so here is our setup. So we've got our setup right here. We've got our figure drawn. We have the rates that they gave us and the numbers that they gave us. So this is our setup. Okay, and after setup, we need a formula. Right? So let's see what they want us to do in part A. Part A, it says, what rate is the area of the circular cross-section? Let's think about that for a second. Circular cross-section, what does that mean? A cross-section is where you would just take a slice out, right? We just take a slice out and that's a circle. So, right, because the top is a circle, bottom is a circle, you slice through, it's a circle. They're just saying, at what rate is the area? So dA dt equals question mark. At what rate is the area of the circular cross-section of the clay decreasing with respect to time. So dA dt question mark. Okay, so we need the formula for the area of a circle. So A equals pi r squared. Okay, great. So that's step 4. We found our equation. Step 5, we take the derivative with respect to t. Okay, so dA dt equals 2 pi r dr dt. Okay, so I'm just going to put numbers in and go look for something if I don't have it. So dA dt equals 2 pi times, they gave us a radius is 3, and dr dt they told us was -1/2. All right, great. So dA dt would be equal to, multiplying all that together, we get -3 pi. Let's see, this is area. So since this is area, the unit should be squared, right? Because that's 2 dimensions. Area is like a sheet of paper, right? 2 dimensions. So inches squared per, and our time was minutes. And that's the first part of this problem. Okay, we okay? All good? All right. So let's look at part B. It's the same, this pink part that I circled, the setup. We're going to use that in all the different parts. Okay, at time t equals c, at what rate is the height of the clay? So we'll pause. So dh dt equals question mark. The height, we want to know about the height. At what rate is the height of the clay increasing with respect to time? Show the computations. The volume of a cylinder with radius r is given by this. Okay, they gave us the formula. That's nice. They usually do. I'm saying they usually give us the formula, but it wouldn't hurt if you knew all your geometric volume formulas. But they usually do give it to us. So they gave us the equation, actually. Am I allowed to put in, I'm having a question, am I allowed to put in a 3 and an 8 right now? No, I am not. I'm not, because are the 3 and the 8 never changing? No, they change all the time, right? The whole cylinder is changing. The height and the radius are changing all the time. So no, we cannot. So we're going to leave all the variables there. So pi r squared h. You're going to be super excited to remember. So what rule are we going to use to take this derivative? Product rule, yep, product rule, yay. Okay, so let's do that. So dv dt equals, so what I like to do is I'm going to make this as f, that part right there, I'm going to attach the pi to it, and this as g. Remember our product rule is fg plus fg, first things first, second things second. Okay, the derivative of pi r squared is 2 pi r dr dt. Copy paste the h plus, copy paste the pi r squared times the derivative of h is 1 dh dt. Okay, and what are we looking for? We're looking for dh dt. That's what we're looking for. Now, we don't have a number for dv dt, but this is where we go back to the original prompt, and I told you this is a really big deal. Remember that a while ago? This, we're going to look right there. Remember this part right here that I like highlighted and circled? The volume is constant. What does it mean if the volume is constant? It means it's like one number, right? One number. If I take the derivative of one number, what is that value going to be? The derivative of 5 would be 0, right? So that's what tells us what number to put here. That's what tells us, is that the volume was constant. So this is 0 equals 2 pi, let's see, what was r? R was 3, dr dt was -1/2, h was 8, these were given to us, equals pi, plus pi, r was what, 3, dh dt. Now that's a lot of arithmetic. Are you okay if I just go to the answer? It's just arithmetic, right? We multiply all those things over, divide, all that. Are we good? Okay. So that goes back to this right here. If the volume is constant, that means it's a number. They're not telling us what the number is, but we could pretend, let's say the volume is 100. So that means that here I would have had 100 here, and I take the derivative of 100 and I get 0. Okay? Does that make sense? Okay, great. All right, so after we do all of our arithmetic, we get dH dt equals 8/3. And height, what kind of unit is height? Is it a 1 dimension, 2 dimensions, or 3 dimensions? It's 1, so it should be centimeters, no, excuse me, it was inches. Inches per minute. Okay. We okay?
We have a calculator.
Normally we would have a calculator for the calculations part, yes. Not, I mean, that we could certainly do without a calculator, but with the more complicated ones, we would have a calculator. All right, now part C, you thought, I mean, part C is weird, I'm not gonna lie. It's just weird. So you're like, no, I don't want weird. I'm sorry, we have to have weird just for a second. Okay, so let's kind of dig into the words here. Write an expression. Okay, so they don't want us to solve anything, yay, but write an expression for the rate of change of the radius of the clay with respect to height. Okay, that is weird. Because what do we normally do? We're normally with respect to what? Time. We normally do whatever dt, whatever dt. What are they wanting us to do here? They're wanting us to do dr dh, which is just weird. I'm just not going to lie, it's weird. So it would be easy to miss that in the text. So the rate of change of the radius of the clay with respect to height. So bizarrely enough, what they're wanting is dr dh. That's what they want, dr dh. The rate of change of the radius with respect to height. In terms of, y'all know that love those math words, don't you? In terms of h and r, that means that I need dr dh to equal h's and r's. I mean, that's what I'm supposed to come up with. That's what those words mean. I need dr dh to equal a bunch of h's and r's somehow in terms of height and radius. That's what that means. In terms of, that means what the equation equals. Okay? So we go back to our volume formula. Volume equals pi r squared h. Now instead of taking the derivative with respect to t, we need to take the derivative with respect to h, which is weird. So dv dh equals, what rule am I going to have to use here to take the derivative of this side? Product rule, yep. I'm going to do the same thing as I did before. This would be my f and this would be my g. Okay, so now remember it's with respect to h. So 2 pi r dr dh plus, times, so derivative of the first, copy paste the second, plus copy paste the first, the derivative of the second. Now the derivative of h is 1, and it's dh, right? See, I've done dht so often, I just like copy it. dh. So that's really just 1. So that's weird. I know it's weird. So what are we solving for? I'm going to highlight. What are we supposed to solve for? We're supposed to solve for this.
Wait, so is dh just 1?
It is 1. No, I don't have to keep the tag there. I put it there so that you would see that it would have been tagged, but it's just 1. So you really didn't have to even write it. So we're solving for dr dh. Okay, we're supposed to have a bunch of r's and h's in it. Well, I see, there's some r's, there's some h's. Okay, I'm happy with that. That goes. This is a problem. But what is that going to be? It's 0. It's still 0. We still have a constant radius. A constant volume. So 0 equals 2 pi RH dr dh plus pi r squared. So again, our job is to solve. We've got to solve for this. All right, so let's move the pi r squared over. So negative pi r squared equals 2 pi RH dr dh. And now we divide both sides to solve for dr dh because that's what they wanted. Dr dh is negative pi r squared divided by 2 pi RH. Now, if we can simplify, we need to, and we can. Those pi's cross out, right? And actually, I have 2 r's on top and 1 on the bottom, 2 r's in the numerator, 1 in the denominator, so those are going to go away, right? I'm just going to be left with dr dh equals negative r over 2h. And that's what they wanted us to do.
You don't have to like plug them in.